Welcome back. We graduate to example problems now. Section 1, Chapter 9, Sinusoidal Sorts. The first example problem, well, this is a homework problem as well, but I want to solve this homework problem completely for you because this is representative of a number of other problems. So if you do this right, a number of homework problems are going to be easy for you. So here goes the problem. Consider the sinusoidal voltage V of t is 100 cosine 240 pi t plus 45 degrees millivolts. Okay, now there are a bunch of questions. What is the maximum amplitude? What is the frequency in hertz? Okay, then what is the frequency in hertz, of course, and what is the frequency in radians per second? What is the phase angle in radians? What is the phase angle in degrees? You're expected to find the time period and the first time after 0 when the V voltage becomes 100 millivolts. Okay, all of these are pretty straightforward. A little bit of thinking is needed for number G, but let's solve those. Okay, let's remember the canonical form, the standard form that Aguilar gave us. V of t is Vm cosine omega t plus phi. Okay, so now let us write the problem that is given to us in this form. V of t is 100 cosine 240 pi t plus 45 degrees millivolts. Okay, now I'm going to color code them really easily. Vm is the Vm is the voltage. Okay, amplitude voltage. The amplitude of the voltage is question A. Okay, so amplitude, the maximum amplitude is really 100. Okay, 100 millivolts. Okay, it's all 100 millivolts. Now, what is the frequency? The Moodle may accept 100 volts because sometimes it may not take into account that millivolts over there. Okay, so if 100 millivolts doesn't work, try 100 volts. Now, what is the frequency in hertz? Pretty straightforward if you think about it. We are looking at problem number B. Okay, problem number B. In order to find that, we look at omega, which is 240 pi. Okay, so in order to calculate F in hertz, remember we are supposed to calculate this in hertz. So in order to calculate hertz, what we see is 2 pi F is really omega, which happens to be this one, 240 pi. Okay, that guy is omega. Okay, therefore we should be able to calculate F from here. F, because we are interested in frequency in hertz, which is 240 pi divided by 2 pi, which comes out to be 120 hertz. Okay, so B is really 120 hertz. Okay, B is 120 hertz. So that's number B is 120 hertz. Number A is really 100 millivolts. Okay, what is number C? We are supposed to calculate the omega, but we already have seen that omega is 240 pi. Okay, omega is 240 pi. Plug in the value for pi, then you will have 7 753.9822 radians per second. Okay, so I can plug that number into here. Let's see, 753. So the answer here is 753.9822 radians per second. Okay, that's done as well. So you see, this problem goes by really quickly. Okay, number C is done. Phase angle in radians. Well, let's start with phase angle in degrees, right? That is the phase angle, right? Phase angle in degrees is really easy to find. Phase angle in degrees is just by observation, it is 45 degrees. So E is 45 degrees. In order to calculate D, which is phase angle in radians, all we have to do is phase angle in radians is phi divided by 180 degrees into pi, right? 180 degrees is pi radians. 45 degrees is 45 by 180 into pi radians. So that comes out to be 0.7854 radians. So let's plug that in. 0. So this guy, number D, is really, so we solved D. Before that we did E actually, as a matter of fact. So this is 0.7854 radians. Okay, so we did A, B, C, D, E. Let us look at F. So this is straightforward. Haven't you seen these problems in the past? Many similar problems in your prerequisite courses, high school courses. So this is really the easy part of it. Let me do this. I'm going to turn the night shift off so you can see the colors better. Now, F, time period in milliseconds. How do you calculate that? So F, time period in milliseconds, is simply 1 over F. But we did calculate F, didn't we? We did calculate F in hertz, which is 120. So this is 1 over 120 hertz. This is going to be in milliseconds. The time period is going to be in milliseconds, 8.333 milliseconds. Okay, so we are going really quickly here, pretty basic problem. The only other problem that is left here is this guy, okay, G. Okay, first time after 0 when V of t is 100 millivolts. So in other words, maybe if you think about it, if you plot this guy, the sine wave is, or the cosine wave or the sinusoid wave is going to look something like this perhaps. Okay, dang it, I don't know. It's going to look like this perhaps. Okay, so you know when the wave, the cosine wave is crossing 0. So you are expected to find out the first time after 0, okay, towards the right of this origin, okay, the first time it crosses a 0. Okay, let us see how we find that out. Now, we are expected to find out G. Let me see if I can copy this. First time after 0, when this guy is, when I'm copying this, oh, excuse me, the first time when this is not 0, okay, but the first time that this goes to 1, okay, the same, almost the same idea applies again, except that I'm not looking at zeros now. I'm interested in finding out the first time, at what time Okay, if this is the time axis, this is the voltage axis. At what time t does my sinusoid, it could be cosine or a sine, cosine in this case, at what time period does this reach its peak value? 100 millivolts. Okay, so here is my cosine wave again. Let me copy the equation for the cosine wave really quickly. Copy this. Okay, there is the cosine wave. Let me clean it up a little bit, like so. Okay, there you go. So now we are expected to find out t, where the amplitude is maximum. Okay, so in order to do that, what we do is that we equate all of this to 1. Okay, when all of this equals to 1, v of t is 100 times maximum value of the cosine wave, which is 1, which equates to 100. Okay, so the trick here is to note that this guy, cosine 240 pi t plus 45 degrees equals to 1, right? Because this, when this value is 1, then the entire cosine value v of t becomes 100 millivolts. Okay, so once we equate that, what we get is, and we have to be extremely careful here, and we'll see how that plays out. 240 pi t plus 45 degrees equals to cosine inverse of 1. Okay, cosine inverse of 1. So cosine inverse of 1 is really 0. 240 pi t plus 45 degrees equals to 0. Okay, because cosine of 0 is 1. Now, from this we really should be able to calculate t, right? T. Let me express this in radians first. 240 pi t plus 45 degrees is pi by 4 radians. All of that equals 0. Now t should be, take pi by 4 to the other side, negative pi by 4, divide the whole thing by 240 pi. Okay, so it's simply a linear equation in t, and I'm solving for t. Okay, that should give us a value of a negative 1 over 4 times 240, which comes out to be negative 1.0417 milliseconds. Okay, let me rearrange this a little bit more, like so. Okay, this is all in milliseconds. Are we done? Yes or no? Think about this. So we were expected to calculate an expression for a value for t. We did find a value for t. Are we done? Not quite, because if you think about it, the result here is negative, meaning we found this time which happens before the origin, right? Before 0, to the left of this y-axis, but we are interested in calculating the first time after origin, so towards the right of this. So how do we calculate that? Simple. We know, see, here is the trick I'm going to use. We know the time here. Okay, let me zoom in on this. We know the time when this given sinusoid reaches 100 millivolts, which is negative 1.417, negative 1.0417 milliseconds. Okay, now I know for a fact, let me make this a bit more bold. Okay, I know for a fact that the next peak happens after one time period. Okay, so this guy happens after one time period. So if I add a time period to this guy, to this negative 1.0417, then that will take me to the next peak in the sine wave. You know, I keep saying sine wave, cosine wave is what I really mean. Okay, so let's do that. Let's to t really is one time period plus this answer that we got, negative 1.0417 milliseconds. Okay, but we did calculate the time period 8.333 milliseconds minus 1.0417 milliseconds. Okay, so that should give you 7.2917 milliseconds. Okay, this is the time. Okay, here is the answer. Time. This is the time when the value of the sinusoid, the value of v of t, okay, all of this becomes 100 milli. If you don't trust me, plug in that number, 7.2917 number into this t, okay, and then calculate out the value. You will see that it equals 100 millivolts. Okay, so we did solve all the problems here, including this one, G, okay, G, whose value is 7.2917 milliseconds. Okay, so pretty straightforward basics. As a matter of fact, you should have seen this from your high school and prerequisite courses. In the interest of completeness, we solved it in a methodical manner. See you in the next example.